Hi, welcome to my presentation. I'm Ritu Ghose. I'm a PhD student at Louisiana State University. In my poster, I'm going to show the detailed basin structures identified from receiver functions in the northern Los Angeles area. As part of the Basin project, we're mapping the structures of the San Gabriel and San Bernardino basins from a dense nodal dataset. I'm going to refer San Bernardino as SB and San Gabriel as SG basin in my talk. The map here is showing the seismic area in SB and SG basins. The basins are outlined in green. The seismic lines are color-coded by deployment year. The blue lines were deployed in 2017, the yellow lines were deployed in 2018, the purple and the orange line is deployed in 2019. Receiver functions were computed using teleseismic earthquakes with magnitude greater than 5.9 and epicenter distance between 30 degrees and 90 degrees. SB6 is the easternmost line of SB Basin. The line is highlighted in the map at the bottom right corner of the slide. The east-west trending line is located between San Andreas and San Jacinto fault zones, but it has no known fault passing through the line. The maximum depth in the SB basin is observed along this line at 1.89 seconds near 5.3 kilometer profile distance along the line. The sediment basement does not show significant changes from east to west along SB6. The depth varies from 1.12 seconds to 1.89 seconds along the line. Another seismic line in the San Andreas and San Jacinto fault region is SB2. It is a north-south trending line. A southward deepening of the basin is observed from the north towards the central part of the line. The basin reaches a maximum depth at 1.48 seconds near station 226. The basin depth decreases again in the southern part near the San Jacinto fault zone. A shallow basin at 0.6 seconds is observed near the projected Loma Linda fault at 9.7 kilometer in the profile. The north-south oriented SB3 line is located in the central part of SB basin. This line shows a shallower basin depth than SB2. The maximum depth is at 0.91 second observed in the southern part of the line near station 384. The shallowest part of the basement is at 0.3 seconds, which is observed close to an unnamed inferred fault near Fontana. The Cucamonga and Etiwanda Avenue faults in the northern part of the line do not appear to exhibit such an effect on sediment basement interface. The SG3 and SG4 lines are in the region where SB and SG basins connect. Both of the lines show a southward deepening of the basement. Along SG3, the basin is shallowest near the Indian Hill Fault. However, SB4 doesn't show a shallow basin near the Indian Hill Fault. It continues the southward deepening pattern. An intercrustal layer has been identified along SG3, which cannot be traced farther south past the Indian Hill Fault. But SG4 shows a continuous intercrustal interface passing the Indian Hill Fault. It is possibly the same layer observed in SG3. Our nodal data provided receiver functions with high lateral resolution revealing more continuous basin structures. The north-south trending line shows a general southward deepening of the SB and SG basin. Exceptions are observed where shallow basin is identified near San Jacinto, Loma Linda, Rialto Colton, Fontana, and Indian Hill Fault along SB2, SB1, SB3, and SG3 lines. The maximum basin depth is observed in SB6, which is in the eastern part of San Bernardino Basin near San Andreas and San Jacinto Fault region. Thank you.